I'm sure you all know, immunology is the study of your immune system and how your body works to fight disease, whether it be viruses, bacteria, tumor cells, or even how the body recognizes foreign tissue such as organ donations and such. And what a key component in your immune system is your T cells, so we've really focused on T cells in that regard, and particularly look at how T cells recognize what is foreign and what is self, and how T cells choose to self-select. To give you a really, really quick rundown of the science, and y'all might be familiar with this in regards to antibodies, but your body randomly creates T cells through VDJ recombination. And so each newly created T cell may specialize to react to a certain cell type. And then we particularly developed genetically specific mice to express mostly one specific type of T cell, which will have a high affinity for, affinity for self. And we were particularly looking at how T cells go through the selection process, so whether T cells that have a high affinity for self are allowed to fully mature, or if they are told to apoptose or die. So we've looked at that selection in the thymus. T cells has that T because they originate in the thymus as thymocytes. So yeah, B cells come from bone marrow, so B bone, if that clears up some of your maybe high school bio. But with this research, it's actually just allowed me to go on and do some amazing things. In fact, our lab actually went to the Midwinter Conference of Immunologists in Asilomar, which not only brings together immunologists from across the country, but also around the world. And these are both professionals and graduate students who come and actually present their research they're working on before it's published. And we actually created a poster of our research and then presented it to, again, graduates and professionals in the field, which was both incredibly nerve-wracking and just incredibly gratifying to be able to present the research that I worked on as just on the same level as research that graduate students are working on. It was absolutely amazing, and in fact, our research won an award at that conference, so we're incredibly proud of that. But don't get me wrong, it was a lot of work. I think before we had to print the poster, we printed at the very last moment, but before that we were in the lab for the past 36 hours straight. We stayed up all night trying to finish it. So it was just a really great bonding experience for my team and I. And of course, a lot of that project occurred in winter quarter, so what we're doing now, spring quarter, is we're reevaluating our data, fine-tuning a little bit more, and we're actually intend to submit a paper for publication, hopefully by the end of this quarter, or if not, at the beginning of fall quarter. So hopefully you'll see our research published in the journal. But this is what I've been working on for most of the year, and I guess I'll open it up to questions now.
Okay. What questions do you have? Now that we know what T and B stands for.
And I actually have a photo of my poster. I didn't bring it here to present because I think it's a little high level for this audience, but I'm really happy to go through it with you. I'm so sorry. It's it takes the immunology course that taught here is a course taken by seniors in their biology fields, so it requires so much background knowledge of cell biology, genetics, and then finally immunology to be able to understand. I'm sorry, I didn't mean that to come across as but I'm happy to walk you through that later if you're curious too.
What questions do you have?
My question is more about where you hope to take the experience, right? Are there things that this has seeded in your thinking about your future interests, or?
Well, I've definitely fallen even further in love with biology from this experience. It's definitely changed my perception of science as something to learn from a book that's sort of very static to something that is more dynamic. Science is happening. I have found errors in immunology textbooks by doing this research, so it's interesting to see just how much the scientific dialogue changes. But for my own future interests, I definitely intend to continue working with Martha well beyond the scope of this partnership, or this, I guess, formal Merrill partnership. But I think because one aspect of our lab is that we, this year especially, have had to bring in new first years to replace us. I've actually been personally in charge of a lot of the teaching of the science to the first years and trying to walk them through biology very, very quickly to be able to catch up to the science we're doing now. And specifically that teaching aspect is something that really stuck with me, so I actually think I want to go on and get a master's in education, hope to teach. But yeah. Okay.
So, can you, just one quick question. If there's a practical application for the primary research that your team was working on, in layman's terms, what would you say that application is?
All right, so we actually have done some experiments with skin grafting, but this would also relate to organ donation. So you know how you have to match a whole bunch of criteria to be able to find a donor? Potentially our research, and then even with all those different criteria, your body still sometimes does reject that organ. This would potentially, way far down in the future with lots more studies, but could allow us to narrow the criteria and produce just a higher success of